Welcome to our Colorado facility, located just outside of Denver in Aurora, Colorado. One of 5 locations across the U.S., it has helped us shave days off our time in transit for our customers. Custom Tool Supply has recently joined the GME Supply and Columbia Safety and Supply family. Custom Tool has spent decades helping contractors in CATV, satellite, and other specialty industries, and joining the GME Supply family have expanded their national footprint. As with our other locations, our Colorado location features a stocked showroom, warehousing facility with option for curbside or dockside pickup, and will soon have a full training center. The GME Supply family of companies are America's premier outfitters of fall protection, safety equipment, and gear for at-height workers. We keep workers safe and productive on the job by offering customers timely service and expertise. Our gear experts are here to be an extension of your safety program, offering solutions and consulting in any way possible to make sure your gear is where you need it when you need it. One of the best ways we can do that is through our national network of distribution locations and training facilities. Everyone expects to be able to order something online or through a gear expert and get it in just a day or two, and that's what our national footprint allows us to do. Let's take a look at the time in transit for standard ground shipping from our various locations, beginning with our headquarters centrally located in Columbia, Missouri. We're local to the heart of America. Our second location opened in Atlanta, Georgia in 2015 to service the East Coast and southeastern U.S. In 2018, our location in the heart of Texas opened in Dallas, further establishing our southern presence. And this year, we've opened a location in Corona, California, where we hosted our last live stream. And just a couple months ago, we welcomed Custom Tool Supply to our family here in Denver, Colorado. As you can see, the majority of the U.S. population is within 2-day ground shipping point from one of our locations, meaning you don't have to pay extra to expedite shipments. And look for our quick ship items, which ship the same day as long as the order is placed by 6 p.m. Eastern Time, Monday through Friday. Thanks for tuning in today, and enjoy the exclusive training session ahead.
Hello and welcome to cold and snowy Aurora, Colorado. I'm Alex with GME Supply, Columbia Safety, and Custom Tool Supply, and I'm here with Mark. Mark, if you want to go ahead and introduce yourself.
I'm Mark Anderson, also with Columbia Safety, GME Supply, and Custom Tool Supply.
Awesome. Well, we're here for our first of 3 training live YouTube training sessions from our latest branch in Aurora, right outside of Denver. And with Mark today, we're talking about rooftop work, working safely with SRLs, horizontal lifelines, foot level tie-off, that sort of thing. So let's go ahead and jump into it. So when you're doing rooftop work, that can mean a few different things. You can either work on a flat or pitched roof or even on the top of a steel structure while it's being erected, right? So regardless of where or how you're on the structure, you're not likely to have a spot above you to properly tie off. So that kind of brings in the foot level tie-off issue. What does that mean, and what are some things to consider when you're working in that type of environment?
So we run into this a lot, especially with, over the past few years, the emphasis into leading edge work as well, which I'm sure we'll go over further. But this understanding between what foot level is and what leading edge is has caused a big gap in understanding proper fall protection as we continue to understand the forces and what can happen to the devices we use to protect ourselves every day. So with foot level, it's first important to know when we say tie off, we're just referring to the point at which we're anchoring above or below in reference to the user's dorsal D-ring on their harness. So foot level tie off is just that. We're using an anchor point that is going to be closer to the foot level of the user because it's allowed to be tied off below their D-ring. That's all the foot level is referencing.
Sure. So like on the edge of a roof or framework, and that kind of goes into the question of leading edge. If you're working closer to the edge of the rooftop or on the top of a steel beam, can you talk about what leading edge and what leading edge is and the confusion maybe between leading edge and simple foot level tie-off?
Yeah, so foot level tie-off is not always going to be leading edge. But based on the way we currently test leading edge products, leading edge will meet foot level tie-off standards.
Sure.
So in a foot level application, an example would be maybe climbing on a column form. You might get to a point where you crawl or climb above your anchor point, which could get up to maybe your feet if you're not paying attention. Now, that might not be proper use, but it could happen. And in that event, if you fall, you're falling straight down the face of the column form, and your lanyard, your SRL, whatever it might be that's been anchored at your feet, is never going to come into contact with an edge that it's going to go over and potentially swing against. So you don't have that added risk factor. Whereas with leading edge, when it pertains to ANSI and the equipment we're discussing, leading edge is saying when you fall, your device is going to be exposed to that edge. And an edge that could be sharp or just rough enough
Abrasive,
to fray,
yeah.
abrasive, anything that could damage, fray, cause integral issues with your device and potentially be fatal.
ANSI has a pretty specific definition of what a leading edge is, and then OSHA has a little broader sense, right? Can you talk about that a little?
Yes, and that is probably where the center of the kind of gray area comes from. So when you're looking at OSHA standards, or in general terms within construction as we know it now, leading edge has always represented a place of work in which there is an exposed edge, you could fall, and it also entails that you are actively working in that direction. So guys laying steel decking, or even like you mentioned earlier, just a simple pitched roof on a residential build where they're laying out the next section, that is an OSHA, a leading edge. Now, leading edge per ANSI, and what you're going to see stamped on an SRL, how it's tested is specific to one scenario, and that is a straight fall over a .005 radius piece of steel.
0.005 inch.
Yes.
Yeah.
Correct.
And that's normally they say like the radius of a pencil, is that?
I don't recall honestly how the layman's term to tell it is, but the biggest takeaway from that is we're not always straight in front of whatever it is we're tied off to, and we don't always know exactly the radius in inches of what it is we're going over. And it's tested to steel, it's not tested to concrete, it's not tested to wood, all things that can have damaging properties, especially in the event of any kind of pendulum motion that the user might experience if they're not directly in line with their device.
Sure. And so that pendulum motion, swing fall, that's often a big consideration with SRL. So let's move on to that. Mm-hmm. So moving into SRLs, either personal or big blocks, there are a few things to consider. SRLs are great to reduce the fall distance versus traditional fall arrest lanyards, right? And when working on rooftops, there are some certain factors that come into play when you're considering the type of SRL to use. So can you go over a few applications for SRLs on rooftops and what kind of considerations should be addressed when putting together a fall protection plan involving SRLs? That's a lot, I know.
Yeah, how much time do you have? You've always got to do your evaluation first and foremost. It'd be amiss to not mention that and see where is the areas you're going to be working in and where can you anchor to. There might be issues with where structural members are placed underneath the deck that you have to have access to get a certified anchor point, especially when we're talking about foot level and leading edge where there can be increased forces. You wouldn't want to skimp on your anchor point, absolutely. So once you've established that, you've got to start considering the radius in degrees in which you're working away, either right or left of the SRL. That's going to create that swing fall issue that we're discussing where perhaps I'm 20 feet adjacent to my SRL and 20 feet out. I'm adding additional payout of the device so my fall distance could be greater, and an entire distance, whatever my edge is, whether it's that .005 inch steel or it's just concrete that hasn't been finished, there's a high potential that I could damage my SRL and potentially cut the line completely, resulting in a serious injury or, God forbid, a fatality. And that's not just to say a non-leading edge lanyard either. Again, the leading edge lanyards and SRLs are tested in one specific way. You can find some manufacturers who are willing to show some independent testing, but in our world, we defer to ANSI for how we label things and how we're making our product selections. And currently, when it comes to leading edge, when you're making that selection and you see that SRL LE label, it's telling us is that it's been tested over that 0.005 inch steel member, nothing else.
That's why it's really important to consider, like you said, where your anchors are, what type of anchorage you're using. Certain blocks or SRLs require a specific anchor to be, paying out and retracting properly, and then know how far left to right on that radius you're working from your anchorage.
Yeah, you bring up a good point about specific anchors, not just as I mentioned about the placement of that anchor, but going back a little bit, no matter what device you're using and whatever labeling you see on it, whether it's LE or not, you still have to review that user manual. And that's where you're going to find some of that information, like we talked about earlier, how certain devices can be tied off 5 feet below a user's D-ring, while others can be tied off 3 feet below. These devices are all referred to by industry names the same. Yo-yos, twin turbos, whatever it might be, whether it does have a brand connotation originally or not, it's just a blanket reference. And you have to take a look and see what scenarios this plays out in and which it'll work in. And same thing with your anchors. Certain of your SRLs, especially in leading edge applications, might call out that the orientation of the SRL has to be maintained in an upright position. This would force you to get an anchor point that maybe has a cradle of some sort that can keep it upright. These aren't just printed on there to make life hard and make your product selection challenging. They're printed on there because every situation is unique and what you need needs to be paired with it.
Well, and that's how they've been designed by the manufacturer and the engineers at that manufacturer is in this specific system. So that's all good information. Let's move on to horizontal lifelines. So when working on rooftops or surfaces without overhead anchorage, a common solution for tying the maximum of the height of the anchored stand is a horizontal lifeline. Whether you're working on a job site flying concrete forming tables, stacking steel, or even residential construction, on a roofing job, a horizontal lifeline could be your best solution. Can you talk us through the different types of horizontal lifelines, or HLLs, and the anchorage options available based on the application, and any other things to consider when speccing in an HLL as means to elevate your anchor point?
Yeah, so as far as types go, you break it down into two primary, which is going to be your temporary and your permanent solutions. So with reference to what we're discussing on an active job site, we're going to be looking at temporary solutions. So from there, it's selecting the materials that it's made out of, the distances you need it to span, and the amount of people that you can have utilizing it as an anchor point for their personal fall arrest system. So considering those, getting those out of the way can narrow down your product a little bit. Then you're looking at your anchor points. Again, checking your manual on whatever horizontal lifeline you do decide is going to be imperative to picking the right anchor points for it. Some anchor points are supplied with horizontal lifeline systems, but typically we're seeing the same anchor points you would use for just direct connection to a lanyard or an SRL, such as a column strap around a concrete column, or wooden roof deck anchors that are spanned between. But again, paying attention to the instructions both on the anchor and the horizontal lifeline is important. Even the anchor installation can be a little different based on the direction the forces are going to be applied in the event that somebody does fall on a horizontal lifeline. Past that, the considerations when we're talking about elevating our anchor point, the big consideration there is the deflection. So we're talking about foot level and leading edge and this cable or lanyard or whatever it might be running over that edge. Just because we've elevated the device high enough doesn't mean that we're not going to go over the edge. It just means that the degree of the angle at which we do will be less. Now that is going to affect the amount of force and also the operation of the device. But again, this is where just taking into consideration what's out there and best practices really matters, because what is that edge? It's not a steel 0.005. So we don't know that at foot level with this device and that edge that this will perform properly. All of a sudden, we're not at a 90-degree angle turn, we're at a much less, but we're not using a leading edge, or we are, and the horizontal lifeline could deflect 3 feet. So while you're tied off what feels like 6 feet above at your D-ring height ends up being 3 feet below. So all of that is required to be in the testing data. You can find it in the manuals, and you can understand that when installed properly, exactly what your deflection is going to be, and then ultimately the result on the device connected to it.
Sure. Well, and I think all that goes back to making sure you have a proper site survey to know what equipment should be spec'd in, whether it's, by the GC or whoever it might be, and whether you need to involve an engineer. Because I know some of the projects that you've worked on, engineers have had to be involved to properly create systems which were safe for the amount of workers that were on it, for the pitch angle that they were working on, that sort of thing. So those are all really important things to consider, not just for Anchorage and for SRLs, but also for the horizontal lifeline in general.
Yeah, I mean, just the whole blanket world of fall protection with the testing and science behind what we can do now and how rapidly we can look at it, we're evolving these qualifiers of products at such a rate, and it's flooded into the market. And that's really a point of pride here with Columbia Safety, GME, and Custom Tool, is that we're diving through all that information and trying to make it digestible for the contractors who are out there in an ever-changing situation, just trying to do right by one another and keep each other safe going home. So walking to a gang box on a site with SRLs and harnesses and lanyards and restraints and just grabbing what you need and going out.
I mean, it's better than nothing, but
maybe. The problem is we can know.
Yeah.
We can know by studying it and paying attention and doing those pre-site surveys and understanding what kind of anchor points are we going to have. Do we have overhead points? What kind of SRL do we need? And this comes down to bottom line costs as well. You could try to find a one solution fits all, but for the majority of the time, then you might be looking at a very high expense that is unnecessary for the safety of yourself or your employees.
Sure. Okay, so talking through leading edge and horizontal lifelines and everything that's involved with that, there's also some edge protection that you can consider too. So similar to foot level tie-off, edge protection is something to consider when working on rooftops. If you're working over the edge on ropes in more of a controlled descent situation, on the edge of structures, or whether it be steel, concrete, or even wood decking, those can be abrasive and cause damage. So what things should be considered and what can be done to mitigate the risk when you're looking at edge protection?
I'm glad you bring that up, because we are seeing a lot more use of ropes as far as positioning and finding ways to access areas of the job site that otherwise were previously require a man lift or something like that. But it is important to note that in these scenarios, where examples would be a swing stage, our vertical lifelines coming around off the edge of the building down for protection while on the swing stage should it fail, as well as, like you said, a controlled descent or positioning situation where one might be going down a main line with a backup line without a walking working surface such as a swing stage. But the same principles at play here. Those ropes are not going to go under a impact. They're in a static load.
A dynamic force.
So we're not as worried about that initial force happening as much as we're worried about small movements, slowly abrading. You're walking back and forth when you're on a swing stage. That rope is moving, and the further we're going down the project, there's getting more movement, and we've got to protect that. So there's a variety of ways you can do that. The simplest that we see out there is carpet squares. People are cutting carpet squares and laying them. Don't like that. Carpet square can easily fall. We don't want to see that happen. Next step is folks will use conduit and put it around it. Again, it's we're getting better. It's fixed in a place maybe, tied back, but realistically what you want to do is buy a rope protector. There's a variety of devices, options, all the way from plastic spirals almost that open, snap around, to canvas that has built-in padding similar to what we'd see in rigging traditionally when we're trying to protect and extend the life of our rigging. And then also mechanical devices. Usually you're getting into those mechanical devices when the rope might in a scenario need to be able to travel up or down, such as a scenario where rig for rescue or something like that, where in the event that an individual were suspended on their vertical lifeline, somebody at the anchor point could let them down with exposing another individual to the hazard. So in those scenarios, we see the mechanical, but all it is dampening that edge essentially, which you always want to do in the event that you cannot get overhead. But as always, if you can get that line overhead in any way, it's really going to do a service to the longevity of your equipment as well as just the safety overall.
Awesome. Well, those are all the questions that I had. If anyone watching either live right now or on the replay wants to reach out to you or any one of our gear experts, how can they do that?
You can reach out to me via email, mark@colsafety.com, or you can reach out to any of us at 404-458-7000. Just let us know your situation. Send pictures if you got them. We love to see, and we're happy to help you come up with a solution that meets your walking, working surface leading edge need.
Awesome. Well, thanks everyone for joining us today. Same time, same place tomorrow. We'll be talking about ladder safety with some folks from 3M. And then on Thursday, we have some RF safety awareness for rooftop work. So again, thanks for joining us, and we will see you tomorrow.